So welcome to Notes and Test and Inspection here at Productronica. I'm delighted to be joined by Ferenc Iradi. Nice to see you, Ferenc.
Nice to see you. Thank you for the chance to represent.
So we're looking here at the X3 inline X-ray system, and you've made an upgrade to it to include from going from 2D up to 3D planar CT.
Exactly.
So tell me first of all, why you did that, and then let's talk about how you did it.
All right. So first of all, thank you very much for this chance to represent our new dynamic planar CT technology, what we are using for 3D inspections. Yeah, so the main reason why we decided to change our 3D approach is that there is an increasing demand from the industry that inspections should be faster and should be detect more sophisticated critical defects. The good old 2D inspection is not fulfilling this requirement any longer because of the complexity of this product. So the 3D is the only option to look behind things that are hidden by other components or they are assembled in multi-layers.
Yes. I mean, the density is obviously increasing with miniaturization, and so you need to be able to see behind these different components. Yeah.
Exactly. And we decided to improve our 3D approach or 3D technology, and it was driven by this industry demand that everything should be faster and also in the same time should have the same or even better quality.
Okay.
And with our new dynamic planar CT approach, we are achieving 2 or 3 times faster reconstruction, and not just image capturing time has been decreased a lot, but also the reconstruction time of the volume has been decreased a lot.
You see. So basically a hardware and a software upgrade.
Exactly. So as you said, there are two main things that have been changed. The one thing is the hardware part. So now our detector is moving in a continuous way, so it's not stopping and going again as we did before.
Yeah.
It's moving continuously. We are grabbing images every 40 milliseconds.
Wow.
And this way we can gather multiple images in the same or much fewer time than before.
So you're getting a lot more image
Exactly.
collection with
Exactly.
it than the step and repeat
Just to
before.
imagine the difference, previously we used 8 or 16 images only for 3D reconstruction. Now we're using minimum 30 or even 60 images, or even higher. Depends on the desired quality or the defects that we would like to detect.
Right.
And the second thing is what I mentioned is the software change. It's also very important because with these multiple projection images, there is a lot of things to do. We have to reconstruct a volume out of it. Mm-hmm. And for this, we need a powerful engine that makes this reconstruction in the shortest possible way.
Okay.
And this has been a big step forwards because now we're doing a reconstruction in a much faster way than before. So actually, when we finished with the image capturing, we almost finished with the reconstruction as well.
What sort of compute power are you putting in behind this?
Yeah, so now we're using the Saturn reconstruction algorithm. It was designed by Siemens. So this reconstruction algorithm is used in CT machines. You know, CT machines are working with a lot of images for the reconstruction, and this engine was implemented into our system. Okay. So this is called dynamic planar CT. It's still not a CT, of course. It's still using the good old planar CT method, but still we can use multiple images in shorter time than before.
Obviously, and then of course the Siemens system is tried and tested, so that's a good working system.
Yeah. Exactly. So as I said, there are many advantages of this technique. Mm-hmm. One thing is the speed, of course. The second thing is the quality improved a lot, obviously because you have more information, much more images, what you can use for the inspection. Mm-hmm. The third thing is, due to the shorter scan time, you have much fewer radiation that is actually exposed to the components. So for example, if you have radiation sensitive components like memory chips, we can inspect them with much more,
Much less power, so the dosage levels are going to be fewer.
Exactly. This
Yeah.
is what I like to tell.
Yeah.
So this way, the throughput can be increased for the customers,
Yeah.
and also in the same time we can increase the capability of the machine by having more information of the defects, and that way it gives a better chance for the algorithm to detect those defects.
Well, it sounds like a very well thought out machine for sure, and it's certainly added a lot of speed and bonuses and better
Exactly.
image quality. So, congratulations and thank you for showing it to us today.
Thank you very much for the chance, and we appreciate the award what has been given to us.